Computer, say hello.
Greetings, all.
In this video, we'll create our own voice-controlled AI assistant in Python. We'll craft a number of modules for our AI brain to allow our assistant to do different things to help us. And by the end of this video, you should feel comfortable in creating modules of your own and adding any functionality to the AI assistant that you really want. I think this is a fun project because it gives us an easy way and a fun way to interact with various APIs available online, and there's just a lot of ways you can develop this AI assistant further. So let's get going. The basic logic of the AI assistant we're building will be pretty straightforward, and we'll leverage existing libraries and APIs in Python. So we'll create a bit that recognizes speech from your microphone, understands those commands as text. We'll build a bit of a parser that parses those commands and looks for keywords, and then does the relevant action if it can identify it. Finally, it should get a response depending on the action, and we will use text-to-speech features in Python to turn that response right into speech. And what I wanted to implement in this video with you is one feature to navigate your computer to a different website, just as a basic starter, then do these voice-controlled queries of Wikipedia for general knowledge. A little bit more advanced, we'll look at how to just compute anything with Wolfram Alpha using their API, and then something else at the end where we'll craft a way to do voice logs with your AI assistant. So I'm here in Visual Studio in my new project with my virtual environment set up. Let's first, of course, make sure we've got the right dependencies going. So I know I'll use datetime in the project. For speech recognition, we'll just use the standard speech recognition library. For text-to-speech, there are a number of options available. Something we can use easily enough is the PyTTS, so text-to-speech, X3. To be able to guide our browser to a given site, we'll use the web browser library. And there are also handy libraries for Wikipedia and Wolfram Alpha both. So let's use pip install to get these key things in. But now we've got the basic dependencies done, and we can start coding. So we've got our text-to-speech engine. We can just initialize it here at the start to have it ready to give us our verbal feedback from our assistant. Let's evoke the initialization. Access the voices property. There's good documentation on this library, of course. And let's set the voice. We'll set the first element of the array, which is the male voice. So 0 in this library is for male, 1 is for female, binary. And this is an easy library to use, but there are more advanced ones you could set up with Access Online. Google's speech generation might give you a more human-sounding voice, or in the future you might train your own AI voice based on your own voice or somebody else's, and then use that. I'll also define an activation word here, so that means that when I start speaking to my AI assistant, it will listen for this word as a command word. So as you might have Alexa or Google or OK Google somewhere else, we can define our own activation word. And I'll just have it as computer. I think the way I'll implement this, I'll just make sure it's one word that you're listening to. So let's start working towards our first method of navigating to a website. Well, we need to have a way to have the system listen for commands. So let's define a method for that. Parse command. We'll create a listener from our speech recognition library, recognizer. So that's going to tap into our microphone and then parse the voice into text. We can give the user some feedback. And tapping into our microphone, whatever is set as the default on your system, we will have a source. So we can set a pause threshold. How long can there be a gap in your speech before it cancels or ends the listening? I believe this uses a Google API for speech recognition, and there might be a limit of maybe 30 seconds at a time. That should be fine for our purposes here. So we're going to get input speech as whatever comes from the microphone. We're going to try and then parse that and recognize it. Let's use a Google recognizer, pass the input speech over there, choose our language preference, EN-US, EN-GB, whatever is relevant for you, and we can then maybe give the user feedback on what that, how well was that speech recognized, whatever that query was. Okay, but we do need to handle the exception here. Exception as our exception here. So we could then come to the user. We did not quite manage to catch that. And later on we might even say that out loud. And what was the error? We can tell that here. Return something blank. Great. Otherwise, we will return this query here. And we might as well define our speaking method. So let's say we wanted to alert the user to the exception here by speech, and we'll be needing to use that many times. So we can create our method that allows the text-to-speech library to actually be useful, and we'll get some speech. So maybe just call it speak, and what we will pass to it is the text. And do we want to vary the rate? So one variable we can change here is the speaking rate, how fast the AI voice is talking. We can give it a default rate, and maybe you might want to vary that for different use cases, however you prefer. So we can then access the engine, the one we've initialized here, and set a property like so. In this case it's the rate property, and we'll just pass on what we've got in the function here. We'll then use the say method very logically to say whatever that text is, and then we will use the run and wait method to make sure it's just running this one, won't start another one until it's complete. So we've got our speak method leveraging the text-to-speech. Should work that way. So we could, at this point, for example, also give the user not just a printed version here in the debugger, but a voice feedback as well. I'll be using this quite a bunch, I bet. Okay, so we've got our two basic methods here, actually understanding what's coming through from the microphone, parsing it using the Google API to convert that into text, and then general method for using the text-to-speech library to actually speak text. Great, some key components for our AI assistant. So now we can start creating our parser and build this little command to go and navigate somewhere and other things. Maybe we'll put a little hello bit there as well. So let's create our main loop. And here maybe we'll say something fun when things are starting up. A bit of MechWarrior lore in there. Oh, we've got the default code already. That's fine. And maybe a loop for listening for commands over and over again until we jump out of it. So let's parse our command. And I think the way we'll do this is that I'll say things like computer, take me to this website, or go to this website. So the first word we expect to hear is this keyword that tells the computer I'm trying to give it a command. And the next one is going to be the specific command, and whatever comes after that is the content of the command. So maybe to handle that better, we could parse this input and turn it into a list and handle it like a list of separate words. Balance it like that. You could do a different approach, but I think that will work nicely. Lowercase for consistency, and just split by words. So we'll get a list, whatever this, as long as there's a text coming back from the parser, the speech recognition, it's going to come and be stored as a list of different words. Okay, so then when do we want to actually act on the commands we get? We'll want to do that if the first word in our sequence is the activation word. So we'll check for that. Maybe we'll remove that activation word from the query so we don't get caught up by it. Everything from now on is part of the structure of the command. And then list commands. Maybe before we do the navigation, we'll just do a basic hello command. So if the query here first says say, so computer say something, and then the word hello is anywhere in the query, it's another way to parse that list, then we can have the computer say our favorite greeting, greetings all. And then if you want to have the computer echo whatever you're saying, so you can bask in the glory of your own creation, we can maybe remove that say command again from our list. And then, okay, join our list back into a string, so go the other way. So this means that putting a space in between each element of the list, we've got our query as a list at this point, and the remainder of it, once the activation word has been removed and the say word has been removed, we'll reconstitute it as a sentence, and then we'll speak that out. So you can have a little echo from your AI assistant. Okay, so that should work. Maybe we'll try it out now. So let's run this. Run Python. PyAudio isn't installed, so let's do that. We install PyAudio. We get this error. The way we get around this error is to download the PyAudio wheel from Python libraries, matching the Python version, your system, download it into your folder, and then we can run pip install locally. That should work. Let's try it again.
All systems nominal.
Computer, say hello.
Greetings, all.
Wonderful. Okay, so we're getting our speech into the system, it's being recognized, and we're getting our command coming through. Basic logic is working, and we can move on to make our next command. And this was going to be navigating to a website. Okay. So we need to decide on what the command is. Maybe it would be go to. So in that case, if the first word after the activation word is go, and the next one after that is to, then we'll start navigating somewhere. And we can say start speaking, and then whatever comes after go to is the destination that we're wanting to go to. So in that case, we'll create a string again, and we'll join the list, and we'll jump ahead to those two words. So instead of doing popping the word away, we could just run a query like that, use this list comprehension in Python. And then we can use the web browser library to open a new page for that query. So that should already be enough. If you want to go and specify the browser that's going to do this opening, this is how you can do that. A bit of browser configuration with the web browser library. So if I wanted to use Chrome, I can set the path for Chrome, which for Windows tends to be under program files, and then register that in the library instance, register Chrome, our browser, background browser, and then we pass the Chrome path we just defined above. So now there's an awareness of Chrome as a browser. So when we are instructing our browser to go somewhere, we can specify explicitly that it's going to be Chrome that we're using. So in this case, we just say get Chrome, as we specify with the name, and it's going to open a new query there. So let's test that out.
All systems nominal.
Computer, go to stackoverflow.com.
Opening.
Ah, and there we go. And it was opened in Chrome as we expected. So, okay, we're getting the hang of this. We're creating commands. We've got our little hello, we've got our website navigation going, and the next thing I promised we would work on is a bit of querying the universal encyclopedia that we have in the world in Wikipedia. So how do we get a response from Wikipedia? They have a publicly available open API. So we use the same logic. If our command word is, let's say, Wikipedia, then we'll go down this branch. We'll create the string again, skipping the Wikipedia command word. We'll tell the user we're querying Wikipedia. And then we will define a method to actually do that searching for us. So let's define a search method. Search Wikipedia with whatever query we've got. So the results will simply be using the Wikipedia library to search for the query. And if there's nothing in the array, we can return some text. We tell the user no Wikipedia result. Otherwise, let's try and find the top option here. So we would say that the wiki page we find would be the very first one. First option in our array. But if it's unclear what that would be, we can handle the exception with the Wikipedia disambiguation error. Have it there. say that the wiki page is just kind of the first. So we'll just grab, in a case of not being clear which one of many similar ones it is, we'll just pick the first. Page would be the first option. First option in whatever the error contains. We can tell the user the title of the page that we're returning and what we want to read out, what we want to have our AI assistant read out would be the summary, I say. So we can say that the wiki summary, of course, is whatever the wiki page summary field is. And again, consult the documentation to understand the structure a bit better. And then we'll return this wiki summary if we haven't returned this null result. So just to recap, we're searching Wikipedia using the Wikipedia library in Python, the module. We'll get an array of results. If that array is blank, there's no result. Otherwise, we'll just grab the first result, unless there's a disambiguation error, in which case we'll also grab the first result from the error, and then return the summary to be read out loud. So we will be getting the result, which is searching Wikipedia with the query. I'll just be speaking the result from the we could combine those into one line if we wanted to. Maybe that's handier. Great, I think this should work, so let's give it a go.
All systems nominal.
Computer, Wikipedia, Python programming language.
Querying the Universal Data Bank. Python is a high-level, interpreted, general-purpose programming language.
All right, thank you very much, Mr. Assistant. Okay, so that worked. We're getting our long Wikipedia summary there, and can just keep chatting to our AI assistant all day long if we want to. So that's Wikipedia covered. Two more things is what I wanted to show here. One was then going on to Wolfram Alpha to do anything that's not just information retrieval, but using the computational engine, knowledge engine in Wolfram Alpha. And they have a publicly available API for this kind of hobbyist experimental use that you can sign up for free. So to get this up and running, is go to the Wolfram Alpha developer portal, sign up, and create an app which will give you an app ID, which is a key you can use. So we'll be doing that. I've done that. And now we can configure it. The app ID, I'll just post it here, and we'll activate our Wolfram client. Create that with our library client method passing in the app ID. So then we've got our Wolfram client registered to our app ID, and we can use that in our searching. Great, so the basic logic here will start out the same. Maybe we will say compute, computer compute. So if it's compute, and in my testing, sometimes it gets parsed as computer. So if at this point the command word is computer or compute, we'll get a Wolfram Alpha query. We'll do the same thing, kind of balancing the things here. Bouncing between a list and a string, I mean. Say computing. And then let's do an attempt. So we will try and get a result. Instead of searching Wikipedia, we'll create a search Wolfram Alpha method, which will be the most complex piece here in this video. And then we'll speak out whatever that result is, or else if there's an error, say unable to compute. Give the user some feedback whenever possible. Okay, so now we need to create this method to actually do our computation. Fine, do it this way. So, okay, we'll do a query, first of all. So the response that we get from the Wolfram engine will be whatever the query method of our Wolfram client returns. And there's a couple of concepts that we can expand a bit on to make the next bit easier to follow. So we get a success, so this returns an object. If that object has a field with the name @success, it means that the query was resolvable. There are these things called pods. There might be number of results, and the highest confidence is given to the first of these pods, which can then contain subpods within them. So first of all then, if the query failed, we'll be able to return a null. So if the response object we look at the success field of it, and if it says false, then things were not good. Let's just return could not compute. Otherwise, the query was resolved. Results is blank to begin with. And we'll get the question. What was exactly asked? So that would be in pod 0. And then the first pod should have may contain the answer. And it's the official result if it has a primary flag set to true, or the title has result or definition within it. So we can do a bit of a complex if statement with that in mind. I'll copy it over actually. So if it's primary or has the title of result or definition, then it's the official result. So we just need to grab on to pod 1 first. So pod 1 is of course the next one down. So if the title value field has a result in it, or the primary flag is true, or the definition is in the title, then we have a result. Get it? And the result may be a list or a dictionary, depending on the response. So we could do with an additional helper method to parse whether it's a list or a dictionary. So list or dictionary, and it will take the variable in there, and if it is a list, so if is instance of the variable is a list, and we'll just return whatever is in the first element of that list. Otherwise, so it's a list of dictionaries, otherwise we'll grab, it's just a plain dictionary, and we'll just return whatever is in the plain text key of that dictionary. So in either case, I'll give a valid result. So then we can say list or dict for our pod 1 subpod. So this is a little bit complex, but if we debug the code here and look at the structure of the response, we might do that in a minute. It'll of course be clear. That's fantastic about Python debugging, easy access to the objects you're looking at and studying. Now these results often come with a bracketed bit after them, so it might be km for kilometers and then expand that km means kilometers within brackets. We don't want to repeat kilometers, so we'll just remove the bracketed section from the result. And then return the result. So we'll take the result and we will split it in the first occurrence of an opening bracket, and then take the first half, so anything up to the point of the first bracket is what we'll return. And now if this condition fails, we'll grab the result, the question from the pod 0, which may likewise be a list or a dictionary. And we'd remove the bracketed section similarly. And then, so we could return the question here. We could choose to query Wikipedia. So we weren't able to calculate in Wolfram Alpha. Should we then query Wikipedia? Maybe. Search Wikipedia with the question instead. A resourceful little AI helper, able to do that. And we'd return that instead. Maybe tell the user we're doing that. So a little bit of a feedback to the user once more. Okay, so that I think should do it for us. So we've got our Wolfram Alpha search method using the Wolfram client with the app ID that we've gained. Not compute. If the success flag is true, then we do have a result query, good response from Wolfram Alpha, and we can grab the result using these heuristics to understand what kind of values make sense. Maybe we'll just pause it there as we're testing to take a look at the structure and see how that works. So we'd say compute something.
All systems nominal.
Computer, compute the distance from Hong Kong to Kuala Lumpur.
Computing.
Okay, so we've gone through this branch. And here if we look at the response, we'll see that there are pods, assumptions, warnings. Success came back as true. There are 5 pods. And the pods are here. For the first 0th one, we get the input interpretation. First one is the result, and here we get the text. And all this element, subpods, plain text. So remembering here, we are returning the plain text field. So we're accessing the first subpod. The plain text will be this. So that's what we should hear.
2,506 kilometers.
Excellent. Wonderful. So now we've got our AI assistant plugging into this huge computational engine in the world, Beautiful. And the final thing, diverging from these queryings, is to have our little logbook, audio logbook. As AI assistants come, of course, they'll also need to be able to listen attentively and jot down your brilliant thoughts. So finally, let's create a little note-taking method. So let's invent a command word, computer log. Tell the user we're doing that. And then after that, maybe we'll listen again, parse a new command. So parse a command. So we would say computer log, wait for the response, and then speak our note. Now we can, we're not taking it into a list or anything, we're just handling it as a string. We want to save this as a file. So with a new file, we'll write it down. And we'll write whatever the content of the new note is, having parsed it. And then say that the note has been written. How simple is that? Now, of course, if we take many notes, we'll just keep overwriting the same file or adding to that log. Maybe we want to keep them as separate files. So we could take a timestamp, time of the current moment, and format it as year, month, date, hour, minute, second, why not? And then we could pass in that variable, the date time, the date stamp, into our note name. Okay, and then just to round this off before we test that out, maybe we'll have a way to exit our AI system, give it a chance to rest. So if we say computer exit, we'll break the loop. Beautiful. Okay, so we've tested everything else. Let's test this too. To be in quotation marks.
All systems nominal.
Computer log.
Ready to record your note.
Today we've built an AI assistant to help us achieve ever greater heights in our coding journey. How delightful.
Note written.
Okay, pretty good. Computer exit.
Goodbye.
Excellent. So, quick review. We initialized our speech engine, defined methods to parse commands using the speech recognition library, and to use the engine to speak. Created a main method to listen for commands. Created these various branches to handle different commands, and that can of course be extended indefinitely and built into a bigger architecture with classes and so on. We did browser navigation, we did Wikipedia querying, we did Wolfram Alpha querying, we did note-taking, and some special commands like speaking back at you, saying hello, saying goodbye, and so on. Very fun little bit of coding. And you can of course take this in a bazillion directions. We've created notes, so you might as well have a method to show those notes or read them back out. You can plug this into your music software. What would be fun would be to maybe train a custom AI voice with your own voice or somebody else's. Of course, home automation is more and more popular, and people do that with existing AI assistants and custom stuff. We've drawn some maps on this channel before, so you could do that more automatically, send messages, handle communications, read poems, whatever. The sky's the limit, and hopefully having seen a couple of examples, it doesn't feel intimidating much at all to go ahead and keep adding to the intelligence of your AI assistant. Let me know if there's something more you'd like to hear or learn, and thanks for watching.